Hello, this is Mr. Huber. In this lesson, we're going to learn about graphing and linear inequalities in two variables. First, let's talk about solutions of inequalities or solutions of equations. In order for something to be a solution, that means that the value of that variable needs to be plugged in to the statement, the equation or inequality, and it needs to make it a true statement. In this case, we have inequalities in two variables, so we're going to have an x and a y, that ordered pair. We should be able to plug that in and have it make the inequality statement true after we simplify and do our calculations. So in this first example here, if we want to tell whether the ordered pair is a solution of the inequality, we want to plug those values in to the inequality. Now keep in mind, this is our x comma y. We have to plug the right value in for the right variable. So the x is going to be replaced with a 12. We're going to substitute a 12 in there for x, minus 3 times the y is 2, so 3 times 2 less than or equal to 6. That will give us 12 minus 6 is less than or equal to 6, which becomes 6 is less than or equal to 6. That is true. So yes, this is a solution of that inequality. 12 comma 2 would be a solution for the inequality x minus 3y is less than or equal to 6, because when we plug it in, it makes the statement true. Let's try another one here. We have 2y minus x is less than 8, and our point is negative 2 comma 5. Again, make sure we plug in the x for the x and the y for the y. Okay, negative 2 the x needs to go here for the x, and the 5 for the y needs to go in for the y. Don't just plug the first number in for the first variable you see. So we're going to have 2 times 5 minus negative 2. Important to have that minus negative 2. Not equal to, just less than 8. So I have 10 plus 2 is less than 8. Okay, 10 plus 2, which is 12, is less than 8. That is not true, so that is not a solution. Okay, that point, negative 2 comma 5, is not a solution for the inequality 2y minus x is less than 8. So again, plug in the values x comma y for the x and the y, see if it makes the statement true. Now let's talk about graphing inequalities in two variables. In order to graph an inequality in two variables, the first thing we need to do is graph a boundary line. So we're going to graph the line like it's an equal sign, not a less than or a greater. I'm just going to graph a y equals mx plus b using our slope and y-intercept, and we're going to make it a solid line if it's got an equal to. Okay, if it's got the equal to underneath the greater than or less than, we're going to have a solid line. If it's just the greater than or less than sign, then we're going to have a dashed line. So we'll see what that looks like. So our line might not be a solid line. It's like having an open circle when we're graphing on a number line. The dashed line is like that open circle when we didn't have the equal to there. And then we want to pick something not on the boundary line. We want to pick a point and test it to see if it's a solution. If it is a solution, then we shade that side of the line. If it's not a solution, we're going to shade every point on the other side of the line. So that's testing a point and seeing if it's a solution, like we just saw in those last examples. But first, we're going to graph the boundary line. So let's look at that in this example. Graph the inequality y is greater than 4x minus 3. So we've got it in y equals mx plus b form. If not, we might have to do some work to get the y by itself, but in this case, it's already set up as y equals mx plus b, so negative 3 is my y-intercept. And then my slope 4, I'm going to go up 4 and over 1. Then I'm going to go up 4 and over 1. I could also go down 4 from that point and over 1. Right? So I'm going to have the same slope along here. I plot my y-intercept, negative 3, then I go up 4 over 1, up 4 over 1. I could go down 4, negative 1. Negative over negative would be like a positive slope. And so now I've got my points I can draw my line through. Because it's just the greater than, no equal to under here. I'm going to have a dashed line. So when you draw your line through those points, it's going to be dashed like this. Okay? Similar to having an open circle on your number line when we're graphing just with one variable. Now we want to test a point. So you want to pick a point that's not on that boundary line. You can pick any point on that, not on there. You could pick 10 comma negative 5 if you wanted to. All right, you could pick 10 comma negative 5. That's not on the line. It helps. You can pick numbers that are easier to work with, so some smaller numbers, maybe some positive numbers. So let's say like 3 comma 1. Okay, 3 comma 1. I'm going to test that point right there. Okay, so 3 comma 1. So we're going to test the point 3 comma 1. And I'm going to plug those into my inequality and see if it makes it true. So I'm going to have 1 is greater than 4 times 3 minus 3. Make sure we put the x in for the x and the y for the y. So I have 1 is greater than 12 minus 3. That's 1 is greater than 9. That's not true. That means that this point is not a solution. So that means this side of the line, every point, any point I pick over here, if I checked it, it would not work. Every point on the other side of the line does work. So I want to shade my graph. Every point over here, that's my solution. Every point that's on that side of the boundary line is a solution. You can pick any point over there you want. Every one of them would work. And you could check it if you want. You could test a point, maybe a 0, 3. That'd be relatively easy to plug in. You could see if that works and make sure it's true. Every point over here is a solution. It's like drawing the arrow on your number line to the left or the right if you have a greater than or less than. Okay, we don't have an arrow here. We have a whole set of points, okay, that we can shade in that are solutions for that inequality. So graph the boundary line, test a point, and then shade based on whether that point is a solution or not. All right, before we graph some more inequalities, a little trivial interlude. So a little break here. What two sports legends were featured on the first U.S. postage stamps honoring individual American athletes? And this happened in 1981. 1981, the first time the U.S. Post Office put individual American athletes on postage stamps. They were 18 cents at the time. Bobby Jones and Babe Zaharias. Bobby Jones, a legendary golfer in the 1920s, he won the U.S. Amateur 5 times and the U.S. Open 4 times. He was featured on the cover of Time magazine as well in 1925, and he helped found and design Augusta National Golf Club and the Masters Tournament. So Bobby Jones, quite a legacy there as a golfer. And Babe Zaharias, a tremendous record as a golfer herself. She won 10 major golf tournaments, including 3 U.S. Opens. She was a 6-time U.S. Female Athlete of the Year by the Associated Press. Not only she was a great golfer, in 1932 at the Summer Olympics, she won 3 medals in track and field, 2 gold medals for the hurdles and javelin, and a silver medal in the high jump. And she was named by the Associated Press the Female Athlete of the Century for the 20th century, and as well by ESPN when they ranked the greatest athletes of the 20th century, the highest ranking female athlete coming in 10th in their overall list. So Bobby Jones and Babe Zaharias, honored for those legendary careers they had, and it's U.S. postage stamps there in 1981. All right, now let's graph some more linear inequalities in 2 variables. So on this next example here, we want to get the y by itself. We need to get that y by itself so it looks like a y equals mx plus b that we can graph as a boundary line. So in order to do that, the first thing we're going to do is subtract x on both sides. So we subtract x on both sides, and we get 3y greater than or equal to negative x plus 6. Then I can divide everything by 3. So I divide everything by 3, and I get the y by itself greater than or equal to negative 1 over 3x plus 2. And so now if I want to graph that, right, I want to first graph my boundary line. So I can graph the boundary line using the y-intercept of 2, and then I'm going to have down 1 over 3 for my slope. Down 1 over 3, down 1 over 3. I could go also up 1 and left 3. I can make the 1 a positive and the 3 a negative. In this case, because it has the equal to, I'm going to have a solid line. So I'm going to have a solid line that goes through those points for my boundary. Okay, because it's got the equal to, I'm going to have a solid line. And now I want to test a point. Because this line definitely doesn't go through 0, 0, if you can tell that, that's an easy point to plug in. I would always suggest using 0, 0 to test, as long as you know that that point is not on the line. So we're going to test 0, 0. In my original inequality, go back up here and plug in 0, 0, not into the inequality I got when I simplified and got the y by itself. So I'm going to take 0 plus 3 times 0 greater than or equal to 6. So that 0 is greater than or equal to 6. 0 is not greater than or equal to 6. So I don't want to I don't want to shade in where the 0, 0 is. So I'm going to shade in everything on the other side of that line. So all of this portion of the graph is my solution. Everything on that side of my boundary line, which again was solid here because I had the equal to. So graph the boundary line, test a point, and shade. All right, now let's see another example here, number 5. We got the inequality 4x minus 2y is less than or equal to 0. Again, I want to get the y by itself. So I'm going to subtract 4x on both sides. Subtract 4x, so I'm going to have negative 2y. Don't forget that negative sign there in front of the 2, minus 4x. And now I'm going to divide everything by negative 2, by negative 2. And when I divide inequality on both sides by negative, I have to switch the inequality. That's very important. That's easy to forget. You want to switch the inequality from a less than to a greater than because I divided both sides by a negative. So my y-intercept here is 0, and my slope is up 2 over 1. So again, I can keep going up 2 over 1. I can go down 2 over 1. I'm going to have a solid line because it has the equal to there as part of the inequality, and that's going to be my boundary line. So I certainly can't test 0, 0 here because it's on the boundary line. You have to pick a point that's on one side of the line or the other. So I'm going to pick a point, let's say 0, comma 3. Right there, I'm going to test 0, comma 3. 0, comma 3. So I can plug 0 for the x, so 4 times 0 minus 2 times 3 less than or equal to 0. So 4 times 0 is 0, minus 6 less than or equal to 0. That'd be negative 6 is less than or equal to 0. So negative 6 is less than or equal to 0. That's true. So that means the point that I tested is a solution, and so I want to shade everything on that side of the line. Everything where that point is included because it worked, it was a solution. And so I draw my boundary line, and then I test a point, and that tells me whether I should shade that side where the point is, or if it's not a solution, the other side of the line where the point is not located. And pick any point that's not on the line as a point to test. All right, let's try one more here. Something a little different because we have a y, no x. We're doing it with two variables. Y equals negative 3. We want to remember what that line would look like. That would be a line going right across where y is always equal to negative 3, and it's going to be a dashed line. That's the boundary line, y equals negative 3. Dash because I don't have the equal to there, right? So no equal to, so I have a dashed line. Now y is less than negative 3. So I could pick a point and plug it. I want y values that are less than negative 3. That will be my y values down here below negative 3. So I could take this on the graph and I could shade in, and everything on that side of my line would be my solutions. Right? So get the y by itself. Know those special cases if it's a y equals horizontal line. If it was x less than negative 3, for instance, right? That'd be a vertical line where x is negative 3. So know those special cases, know how to graph using slope and y-intercept, and then test a point, see if it's a solution, if it makes the statement true, and that tells you which side of the line you're shading for all of your solutions.